But this is what we call the title screen. So it's this picture of the world, and just it's basically a splash page. If we looked at this all across here, you see the RunGTAP interface is sorted into tiles, or pages, if you will. And so here is one called RunGTAP. If you get that, you'll get the history of RunGTAP, some basically about documentation on the software. And then we get over to one called version. And one of the things about RunGTAP that it makes it so useful is GTAP itself, the database, is quite large. It has many countries, over 100 regions, more than 60 commodities. And it would be rare for us to have a focused research question that required that much dimension, especially given the cost of solving a model at that large dimension. And so what's very often the case is we restrict the model, we aggregate a bunch of regions that we are interested in, we aggregate the commodities down to something more manageable, putting groups together that might be of interest to study, maybe keeping some separate on their own, and we do analysis that way. So in essence, we're creating our own version of the GTAP database when we do that. Now, the model will read our current version of the GTAP database that we've made, our specific aggregation, and some of our colleagues may have done a completely different one, and they may send us their version and say, could you replicate my experiment? And so what we wouldn't want to happen is to load their data, their experiments, and have it overwrite or change or get in the way of our own personal work. And so we have what we call versioning, and RunGTAP is a great tool for managing the versioning of this. So what we'll see when we click on this, when we get into RunGTAP itself, is if you click on this, you'll get all the information about a particular version that's been loaded, and it'll tell us what sort of version or flavor of GTAP are we looking at. Is it my current research project, my research project from 2 years ago, my colleague's research project? And so that's what that tab is about, and that's really the hallmark of RunGTAP. Up here at the top, you could see that we're actually in a version right now called NCORS 3x3. That is new course. That means it's the course module, and it's 3x3, 3 regions and 3 commodities. I even have an experiment loaded when I took that screen grab. If we were to describe RunGTAP schematically, what we have on this page really gives us a good overview. So again, we won't know a lot of these terms or these file names that are showing up here at this point, but what we do have are a set of arrows and boxes, and they all filter into and then out of RunGTAP, and that's really the notion we're trying to make clear. So on this box we have some pieces of data, so the GTAP data, the sets, this would be the parameter file. Here we have the model, right? So the actual equation system of GTAP, and over here we have a dedicated box to something called experiment, and this would just be if this is the equations of behavior and this is the data representing the initial or unperturbed equilibrium, then an experiment is a way of moving away from the initial equilibrium. And so this experiment set right here, all 3 come together. RunGTAP organizes those, puts them together as a simulation, a set of simulation instructions, and filters those out. And the most direct item you get is the solution, and then we have some auxiliary files here as well. You get some supplementary looks at the data. You get a new version of the data that is completely updated to the post-sim result, and some other files. And so, as you can see, RunGTAP is doing a lot of work. It is organizing these 3 different components here, all with their own files, all with their own sort of components of instructions, their own importance, bringing those together, setting up a numerical simulation to be run by the computer, by the solver engine, and pass through, and deciding what to write into each of these outputs, and then putting them in a viewable format for us. Okay, this slide wants to tell us about the advantages. Many of them we've already outlined, or at least implicitly discussed. And it is this idea of a visual interface to the GTAP models, this idea that you can click across a few tabs and quickly be up to speed on what information is being used on sort of the initial side of the model, what experiment details are being conducted. This says it automates GTAP simulations, and I want to be clear that automate there means it automates things like handling the files, writing new files into useful locations and keeping them there. It does not automate the process of being an economic modeler. It automates the computing work, the set of instructions. It automates the checks on things that you have to have done beforehand before you're allowed to solve a large equilibrium system. And so in that regard, the word automates is correct. It does not an AI version of economic analysis. But that's you see it. We clarify in the next line. It gives us easy access to output files. It allows us to return to the starting information quite easily. So it's really about being a file handler, an operating system, and a tool that tells us when we haven't completed all the pre-simulation steps. RunGTAP uses GEMPAK as its solver engine. So GEMPAK is the general equilibrium modeling package, and it's just a large simulation engine or equation solver if you prefer, and it runs in the background, and we'll talk a little more about it in this first module, though we won't spend a lot of time. This is a RunGTAP modeling course, so we'll mostly leave GEMPAK in the background, but it's a great tool to learn as well and understand. So RunGTAP helps us keep everything model specific. This versioning within the interface that I've already described, RunGTAP will control the associations, so it's going to build up the folder set and keep them separate so that I can quickly switch back. I don't have to tell my colleague who needs me to replicate something, you have to wait until I finish my work because I don't want to get the files mixed up. RunGTAP manages those associations, keeps them all there, allows you to revert back, right? It gives you this way of backtracking. So if you did decide to commit some changes to the modeling structure or the parameter set that you've, in the middle of a research project, you can go backwards and say, maybe this new path is not working. Let's revert back. And so versioning allows that as well. Okay, let's just kind of review RunGTAP. It's this hub or operating system for GTAP flavored, right? GTAP database as the underlying feature, CGE models. It does follow standard Windows look or implementation. That means if you see something like the file menu, it has the load, the save, etc. So it'll have some specific menus that are important for GEMPAK modelers or GTAP modelers, but it also has the sort of naming conventions that we're familiar with from Windows, so that lowers our overhead. It's a simulation builder. It helps us put together the instruction set. So a general equilibrium model, especially one constructed like GTAP, to be able to be disseminated and used with a lot of flexibility, has a core set of equations and a core set of data, and then the user redesigns the database, usually making it smaller to fit their needs for their simulation. And so it wouldn't be feasible for GTAP to sort of come up with an instruction set for every possible simulation that people want to do, and code that. And so what has been done is the GTAP team built RunGTAP into this simulation builder. So you use selectors, you use Windows type tools and your own sort of calculations and analysis skills to go through and record all the inputs, commit those inputs to a simulation run, and RunGTAP gives you the place to put those. And instead of having to go through and code a full set of instructions for a specific simulation, something we might call a command file, RunGTAP builds those. RunGTAP is the file handler. That's the thing I'll talk about the most. It is certainly possible to run GTAP models, GTAP models from a command line. A lot of people like to do it that way. In fact, a lot of really experienced and important modelers prefer running things from the command line and then just recording the command line inputs that they did in terms of documenting what they've done. But RunGTAP certainly at the training stage makes it quite nice. And then finally, as we'll see when we get to the later modules, RunGTAP has built-in viewers and analysis tools that help us get pretty far into our complete analysis of the post-simulation results. So we want to understand contributions to the change in output of a tariff versus sort of the internal price effect or substitutions. We can do that. We can do that all with a quick few steps from RunGTAP, opening up the analysis tool directly and looking through our results. As a simulation builder, the normal use of RunGTAP, and we'll see it at the end of this module when we begin our simulation, our first practice simulations. Using RunGTAP, the sort of normal form is to go in and choose the version, or just at least verify we're in the version that we want to be, right? We're running the right dimension of countries. In this short course, the online portion, we're mostly going to be running a model that is Sub-Saharan Africa as one region, the European Union as another region, and then the rest of the world. So really a two-region with a residual model and three commodities: food, manufacturers, and services. And so we would check and make sure we're in the right one of those. And if we have the right version, we might choose our closure, decide which equations are turned on and which ones are turned off, which variables are, by choosing which variables are endogenous and which ones are exogenous. There's a standard closure that comes with GTAP, so for the most part, until we get to the on-site course, or the second phase of the training, we'll just use standard closures. We'll use the sort of standard GTAP theory that says zero profits, for perfectly competitive firms, and markets clear the prices to determine exchange quantities. So but you would choose that closure or choose to make changes to it as needed, set up the shocks, and that would be choose which exogenous variables need to be changed, set the perturbation from the initial solution, and then select a solution method. So there are always competing ways to solve a large nonlinear system. GTAP incorporates a few of those, and it also gives us the ability, once we've chosen a solution method, to set what we consider to be the accuracy or the convergence level for the model to call itself solved. And so we'll see all of that. This is the pre-simulation side. Then you commit the simulation. You tell RunGTAP to go and solve our model. And for most small models that we'll see in this, it'll only be a few seconds, and then we'll be ready to look at what we got. So we'll look at the simulation results as well as any other output that RunGTAP generates. So the simulation results, the core simulation results, will always be a set of percentage change variables using the GTAP model. Other output may be some levels of things, right? So what is the updated data? What is the updated GDP, right? In levels terms, in 2001 or 2011, whatever year we're using dollars. the welfare decomposition. So what is the equivalent variation for sub-Saharan Africa? And then how much of the equivalent variation change is due to the EU lowering a tariff, right? And the tariff on food versus the tariff on manufacturers. So all of these things are other output in the post simulation that goes through and is calculated after we get all the key percentage change results from solving the model or inverting that matrix. It's just impossible to talk about RunGTAP without mentioning GTAP some, and we are going to certainly have interface with GTAP quite a bit, but we are training in economic analysis, training in the GTAP model, and we will set a little time aside for ourselves to think about GTAP and what is going on. But RunGTAP is our tool for simulations and analysis. It works with GTAP models, so it's a dedicated software. If you had other type models you wanted to use, you'd have to step back and think about GTAP, and maybe even their tool called, I think, RunGEM. But the main things that we need to know right now from GTAP are two things. One is Tableau, and the other is GemSim. So Tableau is the coding language, or the syntax, if you will, which these models have to be written in. So if we're going to let GTAP be our solver of GTAP, then GTAP needs to be written in the correct syntax and the correct language, and that is Tableau. And if we correctly put together a set of Tableau statements that make a normal and useful model, then we would then RunGTAP or GTAP, either one. We'll send those over to something called GemSim, which is the simulation engine for GTAP. So a way to solve nonlinear equation systems. RunGTAP was designed by the GTAP team. They are not just great software builders for large-scale simulation models, they are also very focused on economists and building tools to help economists do analysis. You can read more about them at their website, the Center of Policy Studies Models website. So COPS, COPS stands for Center of Policy Studies. Okay, just a review on the hierarchy here. We are going to be using RunGTAP. RunGTAP is our simulation builder. It's our file handler. The GTAP programs in the background are Tableau and GemSim. We won't have to engage those. RunGTAP is going to give it the instruction, now is the time to do the Tableau evaluation of the code and make sure the code has no errors in it. And then if it passes that check, it'll say now is the time to send it over to the equation solver, GemSim. And that can be hidden from us, but it doesn't mean that we shouldn't be familiarize ourselves with it. And so we will take steps through this online course, and even more in the second phase of the course when we need more details to understand what's going on with the background GTAP programs. Okay, this closes out where we're at for this first module, first presentation. I would just ask that your next step be to complete the review quiz. These review quizzes are just a way of getting a quick refresher on what the emphasis points were from this presentation. It also helps us document when people are going through the material, how they do. When you completely submit a quiz, you should be able to assess yourself using the provided answer key. Hopefully it has enough details to help you, but also if you have a question, we want to get to that. When you complete the review quiz, you're ready for the next topic, and that next topic will be Software Overview Part 2, where we talk about more formally the implementation of a model. So we mentioned this being about the interface, and so it lets us see the parts of a model. Well, what if we were going to build one up to try to get to a solution? How would we go about that, and what would it look like? And I'll thank you, and again, please do the review quiz, and if you have trouble, need a question answered, there should be some course contact information and email provided that you can reach out with.